Welcome to Universal Theory, where the goal is to find a common language between the abstract and concrete. We are the unorthodox representation of physics and metaphysics. I'm Jordan.
And I'm Trent.
And together, we are Universal Theory.
What's up, everybody? Today on Universal Theory, we're going to be talking about water, something that's kind of like my personality. It's very shallow. This episode is going to be very shallow.
You tricked me. I was thinking about your
You're
sign.
Yeah, it's my sign as well. I'm also a water sign. And we're going to be talking about the structure of water, the types of water, the cycles of water, water in the body, and then some experiments that have happened with water and all sorts of details in between. But before we get into that, thank you for everybody who has been in the comment section, who has been liking the videos. The shorts are getting a lot of traction, and we really appreciate all of you for staying with us since day one. If you're new to the channel, check out our 7 principles playlist. Today we always incorporate our principles into our ideology, and today will be no different. We missed a bit of the principles on the light episode, but we plan on coming back with a vengeance on this one, and moving forward, we're going to be more conscious of that. I see you over there geeking. How you doing? Yeah, that's it?
Yeah.
You're in the flow state?
Yeah, I'm working on it.
You ready? Okay. Yeah, we're doing our thug thizzle over here. Don't forget to like, subscribe, hit the notification bell so you see those shorts that are coming out. The science guy is acting crazy, and the last one, he was all over the screen. And hit that share button. Share with your friends. It's a good time over here. Yeah, we're going to be talking about water, and the principles as they exist. And as we know, as we've talked about in the past, we know that all principles exist within everything. And when I talk about the principles, right, it's the 7 Hermetic principles. We actually, in the vibration episode, if you haven't seen that, check that out. We talked about water quite a bit on that one. And we talked about how water is affected by different vibrations and how we are made up of, on average, 70% water, mostly water. Different parts of the body are made up of different percentages. And that's why when someone's in a bad mood, you can sense that. And that's part of the reason. It's because your water is picking up on those vibrations, what you're made of. At least that's what we're hypothesizing, and that's what we've read. We've done research about water and the body. So go check that one out. That's a really good episode. Here we're going to be getting into more about just water specifically. So the structure of water, excuse me, is something like a peace sign, something like the universal theory sign. So imagine the tips of my fingers as being the hydrogen molecules. As we know, water is H2O. And then imagine the oxygen molecule being kind of where my hand is. And then my fingers would be the bonds between the hydrogen and the oxygen molecules. And because it's shaped like this and not like this, so you can imagine that my fists are the hydrogen molecules and where my fingers touch is the oxygen molecule, and that would be a non-polarized molecule. What we're talking about is this, which is a polarized molecule. So what that means is that the molecule essentially is like a little magnet. It has a positive side and it has a negative side. I believe the oxygen side is the negative side and the positive side with the 2 protons down there by the hydrogens. So we see that water is bonded a certain way, it's structured a certain way, and if water wasn't structured this way, then the body wouldn't be able to use that, and we'll see that later on. And also, the atomic number for water is 8. So just to kind of talk about how that is a thing as well as we're talking about the structure, 8 just means that it has that many protons, and then it has that many neutrons, and then if it's a isotope, it has that many. Or sorry, if it's ionic, it can have more or less electrons. So a standard water molecule is going to have 8 electrons, and oxygen has 6, hydrogen each has 1. It wants to get to 8, right? Elements want to get to a certain stable foundation, and that is having a full outer shell. And a full outer shell where oxygen is 8. And so it goes out and finds these 2 hydrogen molecules, and hydrogen is generally found in pairs of two in nature because hydrogen itself isn't stable, but it fills its outer shell. In that case, it's just two with itself, with another version of itself. So it's like, I've got one, you've got one, we're being made together. Let's just quickly form a bond. So that's why you generally find two hydrogen molecules together. So those two hydrogen molecules find an oxygen molecule, and now you have this stable molecule with 8 electrons. So that's, if you hear about its atomic number being 8, then that's what's happening there. And one more thing about the structure. It's less dense as when it's solid, than it is when it's a liquid. Obviously, when it's a gas, there's a bunch of energy in the molecules and they're flying all around. So this is a very unique property for water, and it's a very important property for water because life as we know it wouldn't exist the way that it does, because that means that the bottom of oceans and the bottom of lakes would freeze before the tops of lakes would freeze, therefore not allowing life to exist in it the way that it does underneath that layer of ice. So that property is extremely important for water. And you already knew that, though, because you knew that lakes froze on top. And when you drink water, or you're drinking a frosty beverage with some ice cubes in it, the ice floats. So you already knew about this, but if this was any other material that I can think of, there might be some exotic ones, the solid version floats because it's more dense. So water is this thing that's the exception to the rule, and because it's the exception to the rule, it allows for life to exist as we know it on this planet.
Yeah, and it's another thing that's interesting about it is, like you said, it's going to float because it's lighter in a solid state. And, they speculate that life was cultivated on the ocean floor because of hydrothermal vents. And so, and there's a lot of life and great biodiversity at the bottom of the ocean around these hydrothermal vents. But also, it also acts as a buffer at the surface between the atmosphere and the water. So the water doesn't freeze as well because there's a layer of ice when it is extremely cold like that.
Right.
So then there's life underneath of it. Because if you're ice fishing and you crack the ice, there's going to be fish under there. They're not frozen to death.
Right.
Unless, of course, the whole lake is frozen, and that's probably not a good thing. But then there are different life forms that can live like when they're frozen, and then you dethaw them. But that's not the point. The point is that you can ice fish because the life is still moving throughout the water underneath of this layer of ice.
Yeah, and if it froze from the bottom up, it doesn't have that protection layer from the elements. Therefore, lakes are more likely to freeze completely over the winters.
Yep.
That's what you're getting at. Oh, cool.
Yep, exactly.
Yeah, there's quite a bit going on with water. We talked about vibration as a principle as it relates to it, and just kind of understanding its role on Earth, and understanding that it, like I said, it's the exception. It has all of these qualities that are different from the other qualities, and that's what allows life to exist. And that is, I don't know exactly why, but in my mind, that has to be something that the ancients, that teachers are tapping into as why water is such a prominent quality. I mean, not only does it fill a vessel, so like a mind filling a vessel, filling the brain,
and it
those
meets
types
its
of
own
things.
measure.
Yeah.
Like if you put water in anything, it's always going to meet its own measure. Like it's going to seep through. If there's a crack, it's going to seep through it. Or or it's going to break through it.
Yeah.
You know what I mean?
Yeah.
Like rain hitting a dry mountain, and then there's cracks in it, and then it breaks those cracks down, and it shapes stuff like over time. And it was also used as a torture method.
Yeah, if you've seen Vikings.
Yeah. And also the fact that it freezes at 32 degrees Fahrenheit, and then in the Kabbalistic system, you have 32 paths of wisdom, or 10 Sephirot, and then you have 22 paths, and then they equal 32 together. And then it's this coherent system of archetypes being manifested from Ein Sof. And then you think that if it rises above 32 degrees, then it becomes in a liquidous state again.
Mm-hmm.
And it's kind of like creation being in a fixed state and then becoming liquidous or fluidic once it transcends and, you know, goes into nirvana or goes into Ein Sof.
Yeah. Yeah, that's and that's interesting because when it was Celsius, it's 0 degrees, so it doesn't quite have that same profoundness to it. I'm sure you could still come up with an analogy.
Yeah, you could say the 0 point, because even in Kabbalah you have Behina Shoresh and you have the 0. It's ground zero basically.
Okay.
So you could still say that. And once again, it's not like these number systems are arbitrary, but it's not like they're absolute. We talked about this in the episode on the fine structure, and we talk about whether or not the fine structure is something that's universal. Well, for us, it is universal, and even though it's an approximation and it's not always exact, and if an extraterrestrial race or someone from another culture had a different system and their system was 5 and ours is 10 or theirs is 12 or whatever, then they're not going to see it in the same light, but it's not like we're not analyzing the same thing. So when people talk about these numbers, like that's, you know, like these sacred numbers, it's something that you have to consider. And then it's hard to get past, oh, well, this number has to exist everywhere.
Yeah.
You know, because what if it wasn't 32 degrees? I mean, just so happen it is, but let's say it was 31 degrees.
Yeah.
Or 30 degrees.
Yeah.
You know, like, would that contradict the nature of your system? Or, you know, would it say that the archetype of your system is off? Not necessarily, but maybe the whole system would be different. But like I said, someone else might use a different number system, but be coming to the same conclusions. So maybe we'll get into that in another podcast. We have Vitaly coming back, and he's going to debate us on some of these topics. So bring your guns, because we're ready.
Yeah. That episode's going to happen. We'll save that for that day. So with water, as we talked about, it has these different structures, and it has there's different shapes that it's going to take. We know about solids, we know about liquids, we know about gases. There's another fourth form that they're saying exists in the body. And it exists definitely in a lab setting. You can make this happen, and that's structured water. There isn't a whole lot on that. That's kind of a new thing that we're starting to understand as a society about structured water. So I couldn't find a lot of research on that I could say I felt comfortable bringing to this podcast. So if you know anything about structured water, let us know down in the comments below if you've heard of that before. And I'll kind of leave the structured water. Well, I'll say one thing about it. Structured water is pretty cool because it starts to form a crystalline shape. So it starts to kind of crystallize because of how the molecules start to line up. They start to line up instead of a positive attracting a negative. It's like the positives are kind of getting pushed together because it's being oriented in a certain way because of its attributes. So there's something to that. I don't know what it is to that. And they say the majority of the water in our body is supposed to be structured like that. So when there's more research on this, I'm sure we will revisit the structured water take in that.
Yeah, I actually seen that there was a lecture on it from the guy who was doing the research primarily, but I didn't watch it.
Oh, okay.
I didn't have enough time. I was like, we're probably not going to cover that much. But yeah, for those of you that know something about it, like you said, say something in the comments, and we'll potentially do an episode on it in the future when we cover more of the data.
Yeah. Yep. So then let's talk about the origin of water. You want to talk a bit about that?
Yes, well, not exactly sure exactly how all of the water got here, but some of the water is extremely ancient, as you will find out. We've more recently discovered that water has made it, to the planet Earth billions of years ago on meteorites. And, some meteorites can consist of up to 22% water. So 22% of the meteorite could be water. Maybe some more, maybe some less. Our planet was heavily bombarded in more primitive times when it was developing in its, original state as it was formulating in the solar system. It was a more chaotic environment, so you had more bombardment. If that happened now, things would be, we wouldn't be able to have this podcast because we might randomly get hit by a meteor. But so it helped contribute to bringing water to the surface of our planet. And as you know, or you may know, or you might not know, and you're about to find out of all the surface area on the planet, water makes up the majority of it.
Yeah.
So out of 196.9 million square miles of total surface area, 139.4 million square miles is water. And like I said, these meteors brought a lot of water here, but we're not sure exactly what percentage of water was brought here by meteors. But meteors are also known to carry life in the form of RNA, amino acids, and so forth. These things that you wouldn't think that can exist out in space, but they can. So that's another thing that we don't really know how life originated here, but it may have traveled here by way of meteorites as well, because we're also made of stardust, basically.
Right.
A lot of the elements in our solar system, and there are other things out there, like I said, such as RNA that may have been the origin of life, or at least contributed to it.
Yeah.
And another thing is with water, and water making up the majority of the surface, and we also have caverns and lakes of water underneath of the surface. But we're not going to get into that. We're going to save that for the stellar human. But on the surface, like I said, the majority of it is water, and then 97.5% of that water is salt water. So it's not something that humans can ingest or non-saltwater animals. But 2.5% is fresh water, and then out of the fresh water, you have lakes and rivers making up 3% or 0.3%. I think it's a very low number. And then 30.8% is groundwater, and then glaciers and ice caps and permanent snow on mountaintops and so forth. That is 68.9%.
Oh, wow. Yeah, so a lot of it we can't even really get to.
Exactly.
And that's something that we're getting more access to as the Earth gets hotter, but there's going to be consequences to that. We'll probably get into that a bit more with the Earth lecture that we're going to talk about. But just to kind of talk about a bit about why so much of the water is salt water, we know that, like Jordan said, it was like 97.5%. Was that what it was? Is salt water. And we can still, right, we've got the cycles of water. So water still evaporates from the ocean. So let's just start there, right? Water evaporates from the ocean. So let's just start painting a picture. It's evaporating from the ocean because of the sun. So it's turning into a gas and going up into the clouds. And then those clouds are getting pushed around by the wind. And in those clouds, there are little dust particles. There's little particles that the water particles start to condense on. And generally those particles, like most things, or always those particles, like most things, they're hydrophilic, which means that they like water. So water is attracted to these particles. And then it condenses, and then it precipitates, right? When the cloud starts to rain, it starts raining. So it rains on high ground, on low ground, all over the place. That rain, water is not salty. But when it hits the water, gravity, right? We know that gravity, where there's mass, there is a warp in space-time, and that warp in space-time causes what we perceive as gravity. But really, it is just a byproduct of the geometry, meaning that it's not an actual force, but we treat it as a force. Everything is going to fall towards that mass because of the warp in space-time. We've talked about this. And that's why that's why the rain comes back down. And that's why it's moving towards the lowest possible point, because it doesn't have a choice. And on its way, flowing through the streams, flowing down the mountains, getting absorbed by plants, getting absorbed by different things that need it, but there's a lot of it doesn't. And it just keeps flowing, and it's picking up particles, it's picking up minerals, it's picking up salt, it's picking up these different byproducts while it's moving down through to get to sea level as it's journeying. and then it gets back down to the sea. Now it's salty, and then it evaporates again. So that's kind of the cycle that water goes through. I'm not quite sure if we know the length of those cycles.
Yes, to some degree. It's not absolute, but it's approximate. So like if it's a biological system, they say that it can stay in the system for around about a week, relative to what the system is biologically. But, you have rainforests, you have animals, you have humans, you have a wide range of different living organisms that have water, and then they perspire, or you lose water through respiration, you lose water through urine, you lose water through defecation, but a week's time normally before it gets evaporated back into the atmosphere.
Okay.
And then if it's in the atmosphere, it's like a week and a half before it precipitates back down. And then the accumulation of, or the condensation of this water accumulating in the clouds through evaporation and then condensating. Certain clouds can house more water than other cloud types, and cumulus clouds can house up to thousands of tons of water. It's like a cubic kilometer.
That's insane. Thousands of tons in the air.
Yes, it's just up there, and it's like it looks like a pillow, but it's super soft and light. But really, it's thousands of tons of water.
Yeah.
And like you said, it's being moved by weather patterns and weather conditions. And then if it's in a lake or a reservoir, it can be up to like 10 years. If it's a river, it's like, I think it's like a couple weeks to a year, maybe. I can't remember exactly.
That's fine.
Yes. And then if it's like a sea or an ocean, up to 4,000 years.
Wow.
If it's groundwater, it can be up to 10,000 years.
Yeah. Okay.
If it's a glacier, I think it's 10,000 years as well.
Yeah, that would make sense, because it's starting to melt again. And I don't know when the last ice age was, but all those cycles, I mean, it makes sense. And you can think about it logically, that that's what's happening in these cycles, and that this water is constantly moving. Like Jordan was saying, so a lot of this water that's on Earth is older than Earth because it's coming from meteors. So the water is literally older than the Earth itself. And we know that the Earth is extremely old, right? Millions of years old. So that's something to consider too. That water, it corresponds, right? As above, so below. These cycles are kind of rebirth. They're reincarnation. It speaks to life and death, and then, evaporating up into the heavens, and then coming back down and gathering all these salts and minerals, right? Moving through life's trials and tribulations. And there's just a lot. There's life cycle. The water cycles are very spiritual.
Yes, and like you were saying, as above, so below, we can make that correlation between the esoteric systems of reincarnation, where you have evaporation, which is symbolic to death, and going back, and like you said, these salts and these minerals that you've accumulated, because they're hydrophilic, they like water, and they attract to water, then it gets released from the water, and then the water goes back to the heavens or the celestial planes, and then it condenses. It hovers at a certain point and it condenses. And you could even connect that to like the group theory of consciousness, where you have different cloud types, or you have the animal consciousness, human consciousness, and so forth. And then precipitation, where we come back down and we are renewed into new bodies, new trials, new tribulations, new experiences. And then we all go back into the ocean.
Right. Yeah. And it's the same water as in the clouds, right? But once you become dense enough, or once enough of those molecules come together, then you descend from the heavens.
Yes, exactly.
So yeah, well, there's some everything you talk about with water. We're going to try to keep pointing out these esoteric kind of principles that exist within the different properties of water. And I think now it's about time probably to get into the body. Before we get into the body, though, I want to talk about the pH scale, just so we have an understanding when we're talking about pH, and just so you know at home, when you hear the word pH, it's a scale of acid to basic, like acid as in hydrochloric acid to basic as in Drano, as in like a cleaner for your house. And then right there, so that's 0 to 14. And then right there in the middle at 7 is water, right? It's neutral. And that's what water is. It's not your standard water isn't super acidic. It's not acidic or basic. What you want to drink is water that is a little more basic. But when we're talking about the scale, and then the principle of polarity applies right there. Acid and basics are two sides to the same coin. They are total opposites because they exist on a spectrum. And if you haven't seen our episode on polarity, I highly recommend you check it out because we talk about the misconceptions of polarity and the misconceptions of opposites. But acids and bases are opposites because you can get to one to the other without having to make any jumps, without having to make any genetic modifications. You go from one thing to the other along this scale. So that's what the pH scale is. They say that we should be drinking water that's around 7.4, 7.5, 7.6. I think the body's 7.4. So we want to drink something that's a little more basic than the body. So that way it has more bioavailability. The body's going to use it more. And because as we know, the absorption rate is affected by
Yes.
it's where it's at on the pH scale, right?
Yes, exactly. The more alkaline the water, but like you said, it's a specific range of alkalinity as well. 7.4, I think they said up to 7.9, maybe even, where it had a more optimal and ideal absorption rate. And then the temperature is also going to determine the absorption rate as well, because if it's too cool, it's going to not get absorbed as quickly or as readily. If it's warmer, it's more likely to, as long as it meets the temperature range of the body naturally. And then there are different ways that water gets transferred throughout the body as well, such as diffusion and then the aquaporine channels. And then one is slower and one is faster. And so you're going to, be looking out for pH levels. If it's more alkaline, then it's more, the absorption rate is higher. If it's more acidic, then the absorption rate is lower. It's not about actually changing the alkalinity or acidity of the body, because the pH scale in the body is around 7.4, but different organs have different pH levels, different locations in the body have different pH levels. And then there's an overall pH level of around about 7.4. So it's not about necessarily making the body more alkaline or making the body more acidic. It's about the alkalinity of the water being able to be absorbed more readily, and then the temperature as well. And then if we're consuming the water, because of the mechanoreceptors in your bladder and your kidneys, when these organs expand from drinking water, whether you're drinking it fast or slow, it's going to cause an expansion, especially if you're gulping it. And if you're causing this expansion, then your body's more likely to want to release these fluids more quickly, because it's like, oh, I'm full, it's time for me to release these fluids. Yeah. And then that's also one of scale circadian rhythms. Yeah, it's kind of like in equals out, right? It's just a common thing you can think of with calories too. When your body has a lot of calories, it wants to exert those calories. When your body has a lot of, or it's going to store it, right? That's what the body does, stores it as fat if it doesn't use it. And with water, it doesn't store it. You can store water in the body, in your cells, but it's still going to flush them. The water's kind of something that can't be stagnant. It always wants to move. Animals can sense the movement of water, and they are more likely, just as a quick fact, they're more likely to drink moving water out of a toilet than stagnant water from a water bottle that's sitting in their water dish, because they have evolved to, that water's sitting, I can't drink it because stagnant water is symbolic with death. Yeah, it could have bacteria in it or something like that. They might have seen other animals, which I didn't know that, but now that you say that, I'm thinking like, well, they probably... it's a survival mechanism. We see this water sitting there. We've seen other animals historically drink it and die. Yeah, we're not messing with it. No matter what the pH level is. I'd rather drink your toilet water than mess with that stuff. It's not like they have a little beaker and they're like, oh, the pH is just right. Let's check the temperature. Oh, yeah, it's good. Yeah, and one more thing about those mechanoreceptors, those are human trained. They're trained by the body. Yes. It's not something that we just grow into. It's not something that everything has.
humans have developed them. That's what wakes you up in the middle of the night, these mechanoreceptors. When you wake up in the middle of the night like me and you have to use the restroom because you drink too much water, that's what's waking you up, these mechanoreceptors. And my 2-year-old daughter doesn't have any yet because we're teaching her, we're potty training her. So right now there's nothing that kicks off in her body that says, I got to wake up because my bladder's filling up. They just release it. Same thing with dogs. Dogs will just release it, and you teach them their body to adapt with these mechanoreceptors or to start to engage with them once you potty train them. And once you say, hey, don't do that in the house, the dog will hold his bladder until it's time to go out, and he'll start scratching when it's time to go out because we have now reinforced this mechanoreceptor in the body.
Yeah, and like I said, if you drink it too fast, you're more likely to secrete it just as rapidly or more rapidly than if you were to just sip it.
Yeah, they say with the first 10 hours that you're awake, you drink 8 ounces an hour. So you need to drink 80 ounces when you're a person at rest. And that's just what your body needs. Like we talked about, the water doesn't sit in your body. It's not like some of these other materials in your body that'll just sit and then you can burn it when you need it. Nope, water is constantly moving. It needs to constantly be flowing. So when you wake up, your body's ready to start purging. Your body's ready to start refreshing the water in your cells, in your different systems. So the kidneys, so the body's saying, hey, give me water, and the kidneys will start working, and it'll start pulling the water out of your body for new water. So they say about 8 ounces an hour for the first 10 hours. So you should be drinking 80 ounces. That's an easy thing to remember. You know, if you got a 16-ounce water bottle, or mine's 24, I know I have to drink that every 3 hours. That's kind of how I do it. So I'm drinking a multiple a day. And then if you're working out, you should double or triple that depending on if it's hot outside. So for that hour, you should drink 24 ounces instead of 8. So that's kind of something to go by. And then that's because it's part of your circadian rhythm. After those 10 hours, the body's like, okay, I purged the water that I needed to. I've replaced the water that I've needed to. My body's going to stop. My kidneys are going to slow down in processing water. And then a few hours later, I'm gonna go to sleep. So,
Yep, exactly.
That's the process for the body. And like Jordan, you talked about the 2 types. You want to talk about that a little bit more, the aquaporin and the diffusion?
Yeah, well, the diffusion is where it goes from the water goes from highest concentration to lowest concentration. So if it's concentrated in a specific area and there's lower concentrations, it will move towards those areas, and they call that diffusion.
Yep.
And then if it's the aquaporin channels, well, these channels are hydrophobic, but they'll accelerate the water through them. And it does so, I think it's like 1 million water molecules per second. That's how fast these channels are. Like, that's how fast the water gets, processed through these channels. And these channels are mostly throughout the body, but not everywhere. So, equal in nature, different in degree. Your body needs water everywhere, but not everywhere will you find these aquaporin channels.
Right. Because it doesn't need them fast.
It doesn't need the water as fast in those specific regions.
Yeah. And when Jordan is talking about 1 million, it's 1 million molecules per second. It's 1 million water molecules per second that move through these aquaporin channels. And that's why I stressed early in the episode why water being polar is so important for the body. Because it's polar, it's like a magnet. So when it's around hydrophobic materials, and in the body, that's like lipids or fat. When you pour oil inside of water and the oil kind of looks like amoebas or like little circles, and it doesn't mix, that's hydrophobic. It doesn't like water, doesn't want to be around it. So imagine that most of your cell membranes, they're lipids. It's a dual membrane, and it's a fat. And so you have these channels through the cells, and that's these aquaporin channels. So when the water molecule gets close to it, it's like a magnet being shot through. It's like if you take a magnet and you orient it a certain way with the negative side down, and then then you have a negative round magnet, and you were to drop it in it, it's going to push it through it because no part of that magnet, the big magnet, the round magnet, wants to be near the little magnet. So it'll shoot it, right, with the tremendous force. And that's kind of what the body's intelligence is taking advantage of here, is that hydrophobic nature, that polar nature of the water molecules. Yeah.
Yeah, it's a beautiful thing. We could talk about, the all is mind, the universe is mental, and how this mechanism has oriented itself in such a way to where even when these components are antagonistic to each other, they're actually symbiotic.
Right.
And you know what I mean? It's like, okay, you don't want to bond with me. Okay, well, I'm going to use you to propel myself to specific areas. So everything is working in tandem and working together, even when they appear to be opposed to each other.
Exactly. And that's kind of like science and religion. They seem to be antagonistic, but they're not. They're working in tandem. Just like hydrophobic materials and water. Remember that.
Yeah, exactly.
Yeah, so we could talk a bit on that. Now let's let's talk a bit about two types of water, right? We've got hard water and soft water. And you've all at home probably have heard about this. Hard water just means it has magnesium and calcium in it. And actually hard water is better for you. Soft water is more acidic. When Jordan mentioned earlier, it's an alkaline infused water, an alkaline high water. That just means that it has alkaline metals in it. And that just means that it has a lower pH, a higher pH, so it is higher on the scale. It is more basic. And with that being the case, you have more of these free hydrogen molecules that end up inside of water when you have hard water and soft water. So when it's hard water, it has higher bioavailability because inside of hard water, and I couldn't find out why in my research, but just that it is. We know that inside of hard water, there are more of these H2s without the O's, because just because you have water doesn't mean every single molecule within that water is H2O. Let's just be completely clear on that, right? Where that's a macro scale when we're looking at water, and when we're talking about molecules, we're going down to micro. So we're going down to 10 to the negative 6. So there are these other molecules that are moving around inside of your water, and one of them is H2. And that's important for the body because when you drink that, now you've consumed your water, which is great, and now you have these H2 molecules. Well, there's these oxygen molecules that move around your body called free radicals. And that's why antioxidants, so you have these oxygen molecules that are moving around, and they call them free radicals, and they damage other cells. They can damage cells and damage different
protein structures
in the body, different things in the body. So what happens is the oxygen wants to bind with the hydrogen, that H2, and the H2 wants to bond with that oxygen. So it'll neutralize that free radical moving around the body, and now you have another water molecule. So it's a win-win situation.
Yeah. And the hard water having more magnesium and calcium, which allows for the increase of the H2.
Exactly.
And then the soft water having less of this magnesium and calcium and less of this H2.
Yeah, and actually the soft water is, because it's more acidic, your body doesn't really want it. So if you drink water that's basically room temperature and it's still kind of, you can feel it moving around in your belly, sloshing around after you've drinking it, your body doesn't want to absorb it. That's probably soft water, and you should look into filtering it or look into finding a way to add this magnesium and calcium to it to try to, or just how to get a different water source in general. And I think that probably brings us to, one of our last topics, which is filtering.
Yeah, and the DBPs.
Yeah, go ahead.
Disinfectant byproducts. So there's a lot of talk about water being negatively impacted by the chemicals that we infuse into the water to rid it of certain toxins and certain bacteria and microbes and so forth, things that could be inimical to us. But then on top of that, the negative is, it's like the positive is, okay, we're getting rid of certain bacteria and certain things that could potentially be inimical to our system. But we're also, in using these disinfectants, we are putting byproducts from this disinfectant process into the water, which then disrupts the endocrine system. So it can negatively impact the nuclear receptors. and it can inhibit, it can alter how our endocrine system works. So it can mess with fertility and it can mess with testosterone levels. And there's also synthetic or organic estrogens, and there's pesticides and glyphosate. There's all these different chemicals inside the water that can negatively impact our health as well. And like we said, fertility, it's like one of the main things that we do on this planet is we reproduce.
Yeah, that's why we're here. Right?
Yeah, and we don't want water affecting how we reproduce or the rate by which we reproduce, or there's also certain science on, they've done research on developmental defects that can come from certain pollutants in water. And of course, this is not going to be universal. This is not going to be everywhere. It's going to be relative to where you're located at and where you get your water from, and what chemical processes the water is undergoing to rid itself of fecal matter and things of that nature, and then the byproducts of those things, which could, once again, like I said, negatively impact your endocrinal system. So those are some things that you should be aware of and probably do your own research, because like I said, it's going to be relative to how that water is being treated. But they are doing research on that. So it's not like someone saying, hey, the water's negatively impacted, don't drink it, it'll kill you. It's like, it might not kill you, but it might mess up your endocrine system.
Yeah.
It could cause developmental issues in a child maybe, and even an animal. If you give it to an animal, they've shown studies where non-human mammals were negatively impacted by certain byproducts of these disinfectants and pesticides and so forth. So it's like, it's just something that you want to be aware of, because maybe you don't want to drink it, but you're like, my animal could drink it. Well, it might not be safe for your animal either.
Yeah. Western society has really found a most magnificent way of moving our sewage away from the home, of bringing water into the home. Just these underground kind of networks of piping and electricity and all these different things. So I don't fault the Western mindset and structural integrity of what we've built, but it's just kind of a byproduct of that hey, we're cycling through so much water. We need to find a way to get it clean. How do we get it clean? Well, we know these things work. And then 10 years later, we have the technology to realize that was a bad thing to put in the water.
Yes. And the fact that, and your wife reminded me of this earlier, where they have done tests on water in specific locations. And I'm not sure where these locations are. I can't remember exactly. And, neither could she. And I didn't have the time to do the research. But,
Sure.
People flushing their medications.
Yeah.
Not everything that goes into the toilet gets ciphered out when the water comes back to you.
Yeah.
So they found residual traces of molecules from people's medications inside of the water that we are ingesting. So once again, it's not an absolute, it is relative, and there is data on the subject, but you should probably do your own research, have your water tested, and buy filters, and maybe even have blood tests done yourself. See what you've been ingesting and how your DNA may have been positively or negatively impacted by the water that is either being filtered or not filtered. Because even if it's being filtered, well, have you changed your filter? How long have you had the filter? What are you filtering out? Is it filtering out all the negative byproducts of this, this waste removal process? Maybe, maybe not, do your research, because it's your health, no one else's.
Yeah. And the problem with that, I think, is like we talked about earlier with the cycles of water. Even if you throw the medications away, it's still going to rain and it's still going to hit it. So
like glyphosate,
there really is no way, once we start to bring all these chemicals kind of out of the ground in their natural state and we start to really mess with them, flushing them is definitely worse because it's a higher concentration of this medication you're putting in a water that might not be filterable. But if you were to throw it away, sooner or later it's going to get into the water system. It's going to, maybe in a slower rate, but it's kind of, hey, this is what we're dealing with, like glyphosate. Like there's, all these, there's quite a few chemicals. I think the best way is geography. We happen to be a mile high, so that helps, right? So because of like we talked about earlier with the cycles, when it rains and it's moving down through these different rivers and such, because unless it happens to rain right over your state and that's the water you're drinking, which, who knows. But being up at a higher altitude, there's less land that the water travels on, so it's less likely to pick up more pollutants and more likely to be, fresher. But I know that where we live, it's still heavily processed water just because it's in a huge city. You can't really get away from it in a huge city. You're not getting enough water to feed all these inhabitants, let alone the 10 cities around you. But you can Google the name of your city and the zip code, and then water analysis, and then you can find out certain things you want to look out for. And there's one thing in particular you want to look out for when you do this that I want to talk about, and that's fluoride. I'm not on the fluoride. We've had conversations about fluoride. I'm not on the tinfoil cap fluoride. Not that there are sides, but I don't think, hey, it's all bad. I don't think the government is poisoning us. Who knows? I don't think that. But I do think we know now as scientists that 0.5 milliliters per liter, so 0.5 milliliters, so that's a thousandth of a liter, so half of a thousandth of a liter in an entire liter is too high. So if you have that much water, if you have that much fluoride in your water, you need to get a fluoride filter. It causes all sorts of health problems. I can't think of any off of the top of my head.
Thyroid,
thank you. Yes, it is
T3, I think.
Yeah, yes, thank you. So it affects the thyroid, and my sister has a thyroid issue. She has a thyroid disease. She has to take thyroid medication. My math teacher, when I was in school, had a thyroid issue, and the thyroid is serious. You don't want to play with your thyroid. It's one of those major things that helps detect perception. You could start thinking you're a whole nother animal and stuff when your thyroid's going crazy. That's what my teacher told me. She thought she was a frog.
Oh, wow.
Yeah. She was hopping around because her thyroid was off. And her parents were like, what's going on? So
that seems like an extreme case.
Yeah, it probably is. But you don't want to mess around with the thyroid, So you don't want to be hopping around like a frog.
No, don't do that.
Yeah, don't do that. So there are filters. Yeah, right. Yeah, lick it out and just people looking at you and rib it in and doing all sorts of crazy stuff. So let's get filters for your water. If you research that, or you just are concerned at all, I have a big Berkey. It's called a big Berkey, and it's this big old stainless steel pot, and people think that I'm brewing coffee. They literally well, you're a coffee addict, and I never got it at first. I was like, yeah, kind of, but why? How do you know that? And then I saw that it looks like a huge coffee machine or tea machine that you get, when you go out to eat Chipotle, when you get the tea.
Yeah. I didn't know what it was when I came here.
Yeah, see, exactly. It's not a common thing, but I highly recommend the Big Berkey. It's not that it's a couple $100 if you've got that kind of disposable income, and the filters last 5 years. I'm still on my first set actually because I didn't use it for a year. Or, at the very minimum, just make sure that the filter you're using is specifically for the chemicals. Because you can't just say, hey, I'm going to get a Brita filter because my fluoride levels are high and think it's going to work. It might. I don't know. But if it doesn't say that's what it's for, then you might be buying something that's taken out. It's solving a problem you don't have.
Yeah.
So just be mindful of that.
Yes. Yeah, it's amazing how water is required for all life. I was just watching something how they went 4 kilometers down in these caves, these subterranean caves, and they were looking for life. And they were like, well, if there's water down here, then that's, for the most part, a prerequisite for life as far as we know. And they were finding life, these 4 kilometers down inside of these rocks. And they're like, it's probably going to be some amoeba or some type of life form. And they found these little worms. They were kind of small, very small worms.
Right, on the size of an amoeba kind of thing.
Well, more I think the nematodes and stuff like that.
Oh, sure.
They were very small though. And they were like, wow, they were just surviving down here with very little oxygen, if no oxygen in certain areas, and very little nutrients, but they had water and they were alive.
Yeah.
And it's just wow, life is, where there is water, there is life, at least on this planet. Maybe on another planet, it's where there is mercury, there is life. But here, where there is water, there is life, and for the most part. And, I was also seeing something about the oceans and the currents and how the water is warmed up at the equator and then it travels to the North or South Pole and then it cools down. And then as it cools down, of course, it goes lower to the ocean. It goes down and then it makes its way back again. And when it swirls, it brings nutrients, minerals, and other organisms with it. When it warms up, well, a lot of this life comes up to the surface and bigger animals will get concentrated there because they're there to feast.
To feed on it.
Yes, and then the eddies as well, where these circulating pools of water in the ocean in different locations because of how the currents move together. They create these eddies, and then they were bringing up life from the bottom of the ocean and minerals and energy and fuel for other organisms. And they were just showing that they have these global patterns.
Yeah.
And it's such a beautiful thing to be like, wow, like the current of water is like it attracts life and it moves life and life flows by way of the water. You know what I mean?
Yeah, it really is. When I think of water, that is what I think of. I think of life more than more than really any other substance on earth. When I think of water, I think of life being brought, and I think of rhythm. When I think of rhythm, I think of the current. I think of the current. I think of the moon cycles that cause the tidal waves. Right? There's all these different rhythms associated with water because water is one of those things that's abundant. We see it everywhere. It's more tangible than air, so we can see things like these currents and we can understand them more visually. We don't need as much technology to see how water is being affected and how it's propagating and how, even in, as closing thoughts, kind of quantum field theory, and it's these vibrations and it's happening in a field that's almost like a vibrating, like a good analogy is like when you drop a rock inside of a lake and you see these concentric circles coming out, and that's kind of what's happening where that rock would be that energy, and now you've got these waves propagating from the field. So water is very much, and I'm a water sign, and I'm a Cancer, so I connect very much with water, and water is very soothing to me. Yeah, I think inside of water you have oxygen molecules that fish can that they can remove from the water. So, even if there is what seems to be no air, there is air. And, you don't find that in the air. I mean, you do in the clouds because there's clouds, right? So there is this kind of dichotomous relationship too there where inside the water there's air and inside air there's water. There's this whole holistic kind of thing happening. And yeah, it's a beautiful thing. The cycles, the structure of water and how it's structured a certain way. And if it wasn't structured that way, we wouldn't be alive. We have the different types of water that we utilize every single day, hydration in the body, and then the minerals, because it's so loving, because water is so nurturing. It says here, take me and put anything in me and I'll absorb it and I'll give it to you and I'll spread it throughout your body. And I'll cleanse you. It's a very, very motherly thing. Yeah. Yeah. And cognition goes down when you're dehydrated. Cellular processes slow down when you're dehydrated. A lot of things go wrong in the body. Like if you have dehydration or cellular dehydration, you're going to have a lot of things slow down because that's how chemicals get exchanged. The chemical exchange happens via water. So it's like, that's why we need water. And you could go without food longer than you can water. Right. Much longer. Yes. Yeah. You go without water for, I think it's like a week in general. Now you might be somebody, I don't want to say exactly what you would be doing, but you might not drink any water for a really long time and you might break a world record. Yeah. But normally you don't want to go without water. Yeah, a couple of days. Yes, exactly. And if you're at a week, you're pushing it, you're on your death cycle. So you might want to get your will together. Get your papers in order. Get your affairs in order. Hit that like button. You beat me to it. Get your affairs in order. Yeah, hit that like button. We move with the rhythm of the water to the like and share. If you enjoyed this content, please like and share. When you like the video, it it recommends it to more people. It recommends it to you and to more people. And we're noticing that with our shorts, that the more people that are liking it, right, it's popping up in their feed. So please, if you enjoy this content, after this, it's going to be, I'm not sure the order, but we're going to do earth and fire because we did light and we've done water. And then we've got some interviews planned, some amazing interviews planned with some amazing people. And then we're going to get into the bulk of the Stellar Human series. So you have that to look forward to. Do you have anything else to say to the people before?
Yeah, so you might want to subscribe now and become a follower because it's about to get super deep. Like you said, we're going to do the whole Stellar, and that's, we're trying not to go too deep into each one of these episodes because we're doing research for the Stellar Human. Yeah. So it's going to get way deeper. It's going to get way more complex, and it would be good if you do the necessary research yourself and, go watch all the other episodes that we've done, especially the principles, because we're going to talk a lot about the principles in relationship to how the Stellar Human comes into existence and how it unfolds and how it goes through the ascension process.
Yes.
So.
Yes. Yeah, and if you don't have time to watch all of them, which we do recommend you do, we have one where we talk about all 7 in the logo. So if you have 7 hours, please watch all of them. I think you'll get a lot from it. Or watch that one because we will continue to use the principles. That is going to be our thing. That's how we plan to marry these two. Science and spirituality is to always mention the principles because those will always have a footing in anything we talk about. We love you. Have a good night. Peace.
Yeah, don't talk to me, it's off to me. Assault police, the archer squeeze. My carpentry is carpeting for all of these. For some seeds, a chocolate scene, I'm Charlie Sheen. I darken dreams, the carpet bleeds. My pulpit leaves a scar with your whole face like a Carter scene. I go hard cause the God of me. You ain't hard as he, or the yard hate. Var hate is the Nazarene.